Good morning. This is Tracy from RX Performance with another how-to install of the RX crankcase evacuation system catch can. What we have here is a new 2014 Ford EcoBoost F150. These notoriously have been experiencing some issues with shutter, misfire, going into limp mode, and then in extreme cases hydrolock and catastrophic engine failure. What we have here is the engine, which is a fantastic small twin turbo 3.5 liter. Makes a ton of power, good fuel economy, all the advances of direct injection for more power out of a smaller displacement engine. But for some reason Ford implemented a naturally aspirated style PCV system. So it is only using the intake manifold vacuum for evacuation. That is only present when you are at idle, deceleration, or very light cruise. Anytime that intake manifold vacuum drops really below 1 inches, you're going to have zero evacuation taking place, and then all the damaging combustion byproducts, the water, sulfuric acid, oil vapor, unburnt fuel, is all going to be accumulating in the crankcase with nowhere to go. This quickly accumulates, condenses, and settles inside the crankcase. Once the crankcase builds up pressure from the blow-by, that pressure is going to seek the path of least resistance. That being out the out the fresh or clean side of the PCV system into the driver's side turbo inlet tube, where it is then pushed into the charge air cooler or intercooler, which most people will refer to it, where it condenses in this liquid gunk, is then mixing, condensing in the intercooler. What happens after you reach a certain point of saturation is you could go into sudden acceleration, merging into traffic, passing a vehicle, climbing a hill, and the sudden turbo boost will push some of this liquid gunk into the intake air charge pipe, into the combustion chamber, where at the very least it causes the misfire in the shutter by blowing out the spark plug spark, so it can't make combustion as designed. And in the worst case scenario, if there's enough of it that has been pushed and forced into the combustion chamber, this liquid cannot compress, and you'll have broken pistons and bent rods and other issues. That, thank God, is in the minority of these, but a very high percentage, I would say the vast majority, are experiencing the shutter and the misfire and the poor fuel economy and other related issues. Another issue long term when you get into the 20-30,000 miles and above are the intake coking issues on the back side of the intake valves that all direct injection engines are experiencing. So we'll go and show you what we have here that comes with the RX kit. You're going to have your dual valve can. If you're in a colder climate, definitely get the monster can because of the rate that you're going to have to empty this out. The clean side separator, which simply replaces the oil fill cap. You're going to have all your pre-cut lengths of hose, the 2 outer hoses that come attached to the outer AN fittings, and these are true AN fittings, not just some caps over a clamp. And we integrate in the one-way check valves into each. And you're going to have your brackets, your nuts and fasteners. You're going to have a 3/8 to 1/2 inch adapter here for the center of the inlet of the can, and various other barbs that you may or may not need all to use, because there's a couple different procedures for routing a catch can depending on how well you want this to function. We also have a drain valve hose here that can be added to the bottom of the quarter turn petcock, which is a simple quarter turn to drain, then close. Or as most people prefer to on the EcoBoost is just to put a cup or a bottle underneath the drain and open it and drain it that way, and do not use this. But this is an option. So a couple of tools. You're going to need a 7/16 inch wrench. You're going to need a socket with a 10mm. You're going to need a open end wrench that you'll be able to tighten the AN fittings to. Do not over tighten any of the fittings. And then we need a drill with a 1/2 inch drill bit that we're going to be drilling into the top section of the filtered section of the OEM air box, or if you have a aftermarket cold air intake, you want to be either in the base of the cone filter or as close to the filter as you can. And first step, we're going to remove the OEM oil cap. We're going to grip the cover and we're going to pull it off. Simply raise it from the front and the back will snap right off. Set this aside. And now you can see what we're dealing with. On the stock OEM system, we have our intake manifold vacuum barb that's right here. Simply pull this off. We have the dirty side outlet valve from the passenger side crankcase, valve cover, cam cover. We're going to pull this off. And we'll set this aside as well, and we'll go from there. So now we've removed the dirty side of the PCV system, and this is where the majority of these oil vapors should be evacuating through the system. But the problem is this being a turbocharged engine, as soon as those turbos begin to spool, which these are a small, very efficient turbocharger, you're going to find that intake manifold vacuum drops below 1 inch. We will have no evacuation taking place, and this is the root cause of all the problems. So we're simply going to remove this line. This is going to, and we do include the factory OEM fittings that slide right onto the included line. You're going to do a minimum of cutting. This is going to feed the center of the catch can, which is the can inlet, and this is where all the exhaust gases, the damaging compounds that enter the crankcase as blow-by, are going to be routed through the can, where it goes through our 4-chamber 3-step process to coalesce, condense, separate, scrub all these damaging compounds out and collect those. So all you've got are some pretty harmless vapors entering your intake air charge, and we're eliminating the cause of the shudder and the misfire. We are prolonging the life of the engine because we're removing those damaging compounds as soon as they enter the crankcase. We're not allowing them to contaminate the engine oil. And we're also increasing fuel economy, because when oil and other contaminants are not present in the combustion process, you only want air and fuel, then you do not have the incidence of detonation. You're releasing more energy per combustive event, and your engine is running more efficiently. We also are removing the compounds that are baking on the backside of these intake valves with direct injection engines. So we're going to eliminate the vast majority of your intake valve coking over the life of the engine. Longer engine life, better fuel economy, less emissions, and you're not going to experience this oftentimes dangerous misfire limp mode when you're accelerating. So we're going to move here to the driver's side, and we have a similar connection. Now, each of these have a small tab You simply slide over and release, and these will pop right off. We're going to set this aside. Now this is the clean side of the PCV system. This should never have oil entering it, and it should always flow clean in and foul out. As you can see, there's all sorts of oil in there. If we can look in here, you will see that. Let it drain for a second. And this as well is full of oil. So this shows that when the crankcase pressure builds, which again, you never want crankcase pressure, you're evacuating the crankcase. And this is the inlet. You should never have these compounds flowing backwards out the end. So as you can see, there's the source of where the oil, water, unburnt fuel, and other compounds that form this gunk are entering, because this is the turbo inlet on the driver's side. You'll notice this gray tab, gray barb here. This is where we're going to connect the secondary outlet from the catch can. Very simple, slide on, we supply the OEM fitting. Our clean side separator is going to replace the oil fill cap, and that's going to get its clean air from the filtered portion of the air box, which is going to run through and enter the clean side separator. We're going to cap the factory barb because this is no longer going to be used, and your catch can is going to use, and let me get the can here, it's going to use intake manifold vacuum for the primary outlet from the can. This will evacuate anytime you're at idle, deceleration, or very light cruise when there's intake manifold vacuum present. The foul vapors exiting the crankcase are going to enter into the center of the can. The secondary outlet, because again, as soon as this intake manifold becomes pressurized, we don't want pressure flowing back through, so we have a check valve in here, in line in the RX cans, that will close when it detects no vacuum present in the intake manifold. The secondary valve is going to open, and that's going to use the suction that's available from the driver's side turbo inlet. So no matter if you're in boost or not in boost, the can is always switching and utilizing whatever the strongest suction source is to give continuous evacuation and prevent these compounds from settling, accumulating, condensing in the crankcase, and then being pushed into your intercooler. So, can is going to mount out here off your horn bracket bolt. It's going to be a nice clean mount here, easy to get at. We're going to route the lines through so they are basically hidden and as OEM looking as possible. The only drilling we're doing for the people that do not want to drill, and we do recommend you drill into both turbo pipes, we will be drilling into both turbo pipes on this application. This person wants the best solution possible. It's going to be into the side of your OEM air box, which we'll remove, install a barb to it, show you how we do that. That's going to connect to your clean side separator. So, first step, we're going to take a 10 millimeter ratchet or wrench, and we're going to remove the horn mount. We're also going to pull the little tab here loose. Just let that go down so we don't pinch the cable for the hood release. We're going to take the small L bracket using the bigger hole here, and we're going to go right back into this. And we're going to fasten that. It's secure. Your horns, we've tilted just a little bit to make sure they're clearing any of the wire harness. Easily push out of the way if needed.
Yeah.
Then we're going to...
Yeah, I want to wait. I want to ship it out after the first.
take the longer nut, bolt, and washer set. And that is going to go through here. We're going to have this mounted down low. The washer goes over to this side because of the larger hole. We'll be able to tighten this together. This is a 7/16. So I brought both 7/16 inch wrench and a simple small adjustable wrench, better known as a crescent wrench. We're going to snug this up.
Yeah.
We're going to pull this out about where we're going to want it. We want to make sure it is not going to hit the brace here on the inside of the hood.
Yeah, one thing we complained about last time, you're buying parts. The pins have one part number, the pins have another.
Then we're going to take the two shorter 1/4 bolts, and again 7/16 inch head on these. It's going to thread into the pre-threaded holes. The finishing process does make it a little hard to start these. We recommend you start the holes first to make sure there's not too much paint on those threads. You're going to take the slot in the longer bracket. I put it in the top two holes. So I will start the center hole first. Then I'm going to take the top hole. And we're going to make sure that we've got both screws.
Yeah. Yes, that's exactly right.
Okay. Take our 7/16 inch wrench. Tighten these up.
Yeah. Okay, thank you. Okay. Nope, not immediately. Okay, thanks, bro. Bye.
All right. Now we're going to be able to have the can here. Easy to get at the drain. Just simply put a empty water bottle or a cup under it. And we're going to begin running our hoses. The first we're going to do is going to be the center. So now what we're going to do is we're going to slide our first hole through, and they're all going to fit right past this deflector flap. There's room to just slide it over, put these through. They're going to come out beside the battery, and if you just do it in the right direction with the hose, you have simply gotten right where we wanted to go. So we're first going to do a 90-degree OEM fitting I spray a little bit of brake clean, or you could use WD-40, carb cleaner even, over it, and that allows it to really snugly make a good airtight fit. Simply snap into place. This is going to be able to fit underneath the engine cover, and it's going to look like it's stock. On this end, we're going to use, give your hose cutter, we're going to use just a stub to go from 3/8 to 1/2 inch. And if you've got a hose cutter, that's great. If not, very carefully with a razor blade, you can just trim this line. And we're going to cut the length here. This is a simple hose cutter you can get at any hardware store. Make sure you don't cut it too short. We're going to slide this on the 1/2 inch portion, and then this is going to slide onto the 3/8 inch portion. Now if you're installing the monster can, you'll note that all 3 fittings will be -8 AN fittings, so you're not going to have to worry about that. So our next line is going to be one of the pre-made up lines with the one-way check valve. You want to make sure you cannot blow in the end. You want this to only flow away from the can, which it does. That's to make sure nobody's made their mistakes here. And we're going to follow the same path that comes out beside. And this is about 1 foot long, too long here, because we want this to go here to where we tee it. Well, it'll be enough for, if this is going to go to the intake manifold vacuum barb that the OEM system used. That's going to be our primary evacuation. So we're going to have a small piece that should already come pre-cut in your kit, just about 3 inches long of the 1/2 inch line. Make sure and then we're going to fit that over the outlet of the check valve, and that's going to slide snugly again. We want to, a little bit of brake clean does a great job here. Just going to put a little on the, or WD-40 or carb clean. As soon as that dries, this is not coming off. That's a nice, clean, solid, leak-free fitting connection. Now back out to the catch can. We're going to screw on our primary outlet. Again, this primary outlet is using the intake manifold vacuum for evacuation. We're going to use our small adjustable wrench, and don't over tighten, just want to snug this. These are AN aircraft style fittings, and give it a clean look. Alright, our next line is going to be the secondary outlet. It's going to go through again in the same area, but when we get up through here, we're going to add a T to this. So let me get it slid up into place. And this gets, as it gets crowded, a little bit more difficult to get in there. There we go. And we're going to come out along with the rest of these. Now this, we're going to have a T added to it. So we're going to cut this to length. So we have the other end of our secondary outlet. Again, we're going to thread this onto the can, the 90-degree AN fitting. Take our adjustable wrench and just snug this. Don't over torque it. These are designed to seal and seal well. The other end that we have here, we're going to be setting up with our T, because we're going to be tapping into, in this case, both inlets, driver side turbo inlet tube and the passenger side. Now the passenger side will need to drill. If we were using driver side only, we would just continue on with this piece, run it either over or under the throttle body right here, and we would connect it over to the factory barb that we have on the other side. So, all right. So again, we're gonna find our little piece here. This should already be pre-cut, but if it isn't, you need a piece approximately 3 inches long. You're going to grab the enclosed T, and this is going to go on to our stub right here onto the outlet of the check valve. Push it on there nice and snug. Now we're teeing to both turbine inlets, and we're going to be using the suction for both for our secondary evacuation while in boost. And Ford uses the intake manifold vacuum for evacuation with their turbos. GM uses the turbo inlet suction for the evacuation of theirs. They have a similar issue, just about as severe. All we're doing is using both principles, which couldn't be simpler in my book, but apparently it is too difficult for them. So we're going to measure. We're going to need approximately, I'd say, 10 inches of this line to go to the passenger side turbo inlet. That's going to go on to the end of the T that you have clocked toward the passenger side. We're going to slide it underneath here, and we're going to be going into, in this case being a new one, you can see there's already a molded boss here, so we can easily drill into that and add our fitting onto that. So the fitting we're going to be using today is a 3/8 NPT by 1/2 inch barb. We're going to drill a 1/2 inch hole into this inlet tube. That can be done into this barb itself. And don't be afraid of any of the small plastic debris that gets in. Will pass through the system without causing any issues, where if this was metal, we would want to remove this. Okay, most of the debris comes out the outside. We're going to want to screw this into that hole. We include a small steel or brass threaded plug that you're going to be able to cut your threads into this. Or what we're going to do here is use a standard 3/8 inch NPT male tap. Now, ideal would be to place your inlets as close to the turbocharger inlet as possible. But that's difficult to get at for your average do-it-yourselfer, so this is going to suffice just fine. So we're going to cut some threads into this.
So we can simply screw our barb in. And again, you won't have the tap included. If you do have a 3/8 NPT, National Pipe Thread tap, then by all means use it. If you don't, the threaded plug that we include in the kit will cut the threads as well. Okay. All right. And again, you would not want any debris of metal, but this soft plastic will pull through the system on initial startup without causing any sort of issue. Now we're going to screw our 1/2" barb into the threads we just cut. If you feel better, you can seal this with some RTV or similar. But this does a nice, it's a tapered thread, does a nice job of sealing just as it is. And remember, this will just have suction on it, it'll never have pressure on it. Okay, we've accomplished that. We're going to firmly slide the other end of our secondary outlet T-hose on. And now we're going to move to the final. This easily, instead of going around the rear like we were doing before and wasting a lot of line, we're going underneath the throttle body. We're sliding and attaching this to the T, if you can see that T. And this is going to be our driver's side. Now the driver's side, we're simply going to make sure you have plenty of hose. We're going to mark our length. Cut the length. We're going to take our other OEM barb. I've sprayed a little brake clean on it as well, so it'll easily slide on all the way. Barb simply clicks on to that OEM barb, existing barb, and now we have the plumbing complete for the catch can, for the dirty side. We're going to take our 1/2" vacuum cap, and it's snug. We're going to slide that over the open barb on the valve cover because we can't leave anything open. This is a closed emissions compliant system. And now we're ready to reinstall the engine cover. And this truck has how many miles on it, David?
About 2,500 miles.
So 2,500 miles, the truck is new, but we're still strongly recommend that the charge intercooler be removed and cleaned. Now, you're going to get this to snap down in. Everything's in place. We're going to install our clean side separator instead of the oil fill cap. And if anybody hasn't seen how this works, once the clean side separator is installed, we're first going to install the cap itself alone. You'll notice some assembly grease. You can take and spread that around your O-rings, because once this cap is in place, you simply twist and pull off anytime you want to add oil. That's simple. So this is first going to go on just as your OEM cap. Push it into place. It's a 1/2 turn clockwise to lock it. Simply push on your clean side separator, which is sealed by the O-rings, And now our filtered fresh air is going to come from the top side of our air box here. And for that, I'm going to use a 90-degree fitting. You may wish to remove again the top of the air filter. We're going to be going right into the side of it. The top portion is the filtered portion. And we're going to do the same thing and cut threads into this. Let's see. And the plug that we send with is a little bit easier, it's shorter. This one is tap is not going to fit in there, so see if I can get this to thread itself in, and I can. Okay. From here, this again should be a pre-cut length. One end is going on to the clean side separator. Give yourself enough length here so it's got no chance to pull itself out. Underneath the overflow line, onto the fitting, and now we've completed the install. Filtered fresh air is entering your driver's side bank of the engine, traveling through, replacing the displaced foul vapors, damaging vapors being evacuated out the passenger side. All goes through the oil separating catch can system where we're scrubbing, cleaning, removing these, and we have harmless vapors then that are going to go through the truck. One final step now is we're going to start it. Now we have eliminated the issue of the gunk accumulation in the intercooler causing the stutter, misfire, and engine hydrolocks. We will initially be pulling out, so the first 300-400 miles are going to accumulate more than it should after that, as we're pulling out what's been settling and accumulating in the crankcase. We have increased mile per gallon, approximately 1 to 3 on average. This owner of this truck will track that fuel economy and verify that as well as the rest have. And the reason is we're not contaminating that intake air charge and causing detonation and incomplete burn of the air-fuel mixture. And that should do it. Start it up. We'll check for leaks. David, if you want to give it a start here. Should throw no check engine light. Make sure you're only using the inlet pipe and not the charge pipe from the turbo. That all of your fittings were on good and secure. And we're going to test to see. We're going to pull the line from fresh air, put a finger or a thumb over, and we should feel the suction building. That is going through, filtered fresh air through the system, flushing out the damaging compounds. We've corrected the flaw in the OEM PCV system. We've done so quite simply.